Today, the topic that we are going to discuss is about the electric potential and the potential difference. Now, what is electric potential and potential difference? Okay, so suppose a question arises. The first question that is given here: what makes the electric charge to flow? That means what makes the charges to flow from one point to the other point. That we'll be discussing. So for that, we'll be going through an analogy of flowing of water. Okay, so see the analogy, how does the analogy helps us to define the electric potential and the potential difference. You can see it here that there are two beakers. Here this is beaker A, then this is beaker B. Okay, the first beaker is full with water and the second beaker is, suppose it is having a water level up till here. Okay, and we have a suppose a closing part, and these two beakers are connected to each other from the bottom. Okay, and suppose it is connected by bottom, and also we have a stopper such that the water from A cannot flow to the B. Okay, now suppose if I open this stopper, then what will happen to the water? So you will be seeing that when you open this stopper, if you suppose open the stopper, the water will be flowing from the beaker A towards the beaker B, and you'll be seeing after some time that both the beaker will be having the same level of water. Okay, that means if you consider here the first beaker A, okay, the first beaker A. So as you can see, this beaker water flows from beaker A to the beaker B. So what happens in the beaker A? Why does it flow from beaker A to beaker B and not from beaker B to beaker A? Okay, the reason behind it is here that this beaker A, it is in a high pressure region, and this was initially it was in a low pressure region because the amount of water level here it was more and here it was less. So we can see that the water that is flowing is from the high pressure region to the low pressure region. The same way, if you consider in terms of a battery, so battery we have two terminals, positive terminal and we have a negative terminal. So the bigger terminal is represented positive, the shorter is a negative terminal. So here you can see this high pressure region is nothing but your A. Okay, so nothing but this positive terminal, and the low pressure region is nothing but your negative terminal. That means, suppose if I connect it to the circuit, any of the circuit, so in which direction your current will be flowing? Similarly, like to this high pressure region to the low pressure region. Since here this is a high pressure region and this is a low pressure region, and there is nothing in between, so it will be flowing from high pressure region to the low pressure region. That means the current will be flowing from positive to the negative terminal of the battery. Okay, so this is how we can determine the direction of the current. And why this battery gives a current? Because of the potential difference. This is high potential and this we call as a low potential. That means high pressure region we can consider as a high potential region. The negative terminal we can consider as a low potential. So high potential minus a low potential, that is called as a potential difference. Okay, now suppose if we want to move a charge from this positive terminal to the negative terminal, what we have to do? Suppose there is a charge placed here. Suppose Q charge is placed here. What we have to do, this positive charge, suppose this is a positive charge, this will apply force on the positive charge. Okay, and if you want to move this charge, we have to do some work on it. Okay, so that work done on a certain charge to move from one point to the other point, that we call as a electric potential, which is given by electric potential is equals to work by charge, that is W by Q. So if I calculate this SI unit, work is joule and coulomb, charge is coulomb, so it is joule per coulomb, or we used to write this as volt. And how we can measure? This can be measured by using our instrument called as a voltmeter. Okay, and this voltmeter, it is similarly like to the ammeter, only ammeter measures the current, voltmeter measures the potential difference in a circuit, and this is connected in a parallel connection. Okay, so this is your electric potential and the electric potential difference. Okay, so suppose in a question, this is an important part. Okay, this comes in your exam to draw an electric circuit. So suppose a question comes drawing electric circuit comprising of a cell or a battery, an ammeter, a voltmeter. But this voltmeter, it will be given the question that this voltmeter should be connected across a certain appliances. It will be given the question. Like suppose connect the voltmeter across a bulb. Okay, I'll be showing the circuit. Then we have a bulb. So if you show in the smart board, we have seen that the direction of the so the representation of your bulb was different. You can use the bulb representation this way also. Okay, this is the most easiest way. Then we have a rheostat. This is a rheostat. You can see, if you see the symbol of the resistor, resistor has the symbol in this way. Okay, there is no arrow in between. But the rheostat has an arrow in between. This represents it is of variable resistance and this is of fixed resistance. Fixed resistance is shown by resistor, variable resistance is shown by your rheostat. Okay, then suppose it is given to draw a key. There are two types of key. One is an open key and one is a closed key. You can draw in this way also. Okay, so if in the bracket inside there is no dot, that means it is represented as open. And if there is a dot in between, this is called as a closed. The same way the closed can be represented this way and the open can be represented in this way. Now let us draw an electric circuit now. So if I draw the electric circuit, I will be going from one by one. First I will be connecting your battery. Okay, this is a cell or a battery. Then I will be going to the suppose ammeter. Okay, but while drawing the electric circuit, always remember that this positive terminal and the positive terminal of the ammeter should be connected in the same way. Okay, this should be the positive and the above one should be negative. Then I will be going to the next. Suppose I will go to bulb. This is a bulb. Okay, and suppose if the question is given, connect the voltmeter across the bulb. So I will be drawing a voltmeter here. Voltmeter. So here this should be positive and this should be negative. This positive and positive should be connected to the positive terminal of the battery. Then if I go to the rheostat, you can draw in this way also by giving an arrow, or you can draw in this way. There are two ways of drawing rheostat. Okay. So rheostat I have done. Then I will draw with a key. You can draw a closed key or you can draw a open key. So suppose if I make a closed key. So if you make it a closed key, as I have already discussed in the potential difference, the current always from the positive terminal to the negative terminal of the battery. So the direction of the current will be from positive to the negative terminal of the battery. This is how we have to draw the electrical circuit. Okay, now like the series and the parallel connection in the resistor, I will be again revising the topic, that is series resistance and the parallel resistance. We have an activity in the book also. So I will be going through this. The first you see the series. As I have already discussed, in the series connection wire events, the current always remains same and the potential difference is different across all the resistors. How to check it? Suppose if you draw, this is a series connection circuit. Okay, R1 and R2 are taking two resistors which is connected to a battery, suppose having a voltage V. Now, how to see whether your current is same or your potential difference is different? What I will do, I will be connecting an ammeter here. Okay, like suppose if I connect an ammeter here. Okay, so this should be connected to positive, negative. Okay, so if I connect the ammeter here, suppose this voltage, that is a the battery is giving a current around suppose 3 ampere. And then 3 ampere current will be flowing because the current flows from positive terminal to the negative terminal. This is the direction of the current. So as soon as it is flowing to the resistor R1, if I see the ammeter reading, I will be getting a reading of 3 ampere. Okay, the same way, if I disconnect this ammeter and if I connect in forward, that is in front of the resistance R2, again you will be getting the reading of the current as a 3 ampere reading. That means, as I have already told you that in a series connection the current always remains same across the resistors. So the current across R1 I have got 3 ampere, the current across R2 also I have got as 3 ampere. Okay. That is the first conclusion. Then if I go to the second part, then the potential difference is different. So if I connect a voltmeter across here parallelly, okay, suppose this I have connected around 5 volt battery I have given here. Okay, if I connect a 5 volt battery, this is connected, this voltmeter is connected to the first resistor. What reading you will be getting? Suppose I am getting a reading of around 3 volt. Again, if I connect a voltmeter here, okay, you will be getting a value of around 2 volt. So as you can see across both the resistors, first resistor is also showing different potential difference, second resistor is also showing different potential difference. That means I can conclude that potential difference across the resistors is always different. But the condition is that this 3 and 2, if I combine it, I should get 5 volt. That means if I write in place of this as V1 and if I write in this place of V2, okay, that means I will be getting as V will be equals to V1 plus V2. Yeah? If I use the Ohm's law, V we know it is equals to I into R. It is equals to I into R1 because the current across, if I consider here, if I use the Ohm's law across the resistor R1, V is equals to IR. I is same across both the resistors, so I will be the same, this I only. And if I consider V is equals to I into R, I is same for the resistor, and for the resistor R1 I can use in place of R is equals to R1. Same way, if I use in place of V2, I will be adding as R2. Now you can see I can take I both sides common. So what will you get? You will be getting as R is equals to R1 plus R2. So this is the formula for the series resistance. If I use more than 2 resistors, it will be plus R3 plus R4, it will be going on like this. Now let us see the parallel connection. The current will be flowing in this way. If I use an emitter here and if I use an emitter here, what will be the reading you will be getting now? Okay, so this is again I am connecting a V volt. Suppose it is giving a 5 volt battery. So this current when it flows through this resistor, you will be getting that. Suppose if this gives a value of around current, suppose 3 ampere it is giving. Across the first resistor, you may get a reading of around suppose 1 ampere. Across the second resistor, you will be getting around a current reading of 2 ampere. That means you can see the current across both the resistor is different. But if I combine this 1 plus 2, this is equals to 3 ampere. If I combine 1 plus 2, I will be getting again is equals to 3 ampere. That is a total current flowing in the circuit. Okay, but if I connect a voltmeter here, okay, and if I connect a voltmeter parallelly here, what will you get? It is giving a 5 volt. If I connect a voltmeter here, this also will be getting 5 volt, and this also reading you will be getting as a 5 volt. That means potential difference across both the resistors are the same. That's why I have told you that current is different in the parallel connection across the resistors, and potential difference is same across the resistors. So this current will be getting splitted up into, like suppose if I consider this current will be split up into I1 and I2. Okay, the currents are different, and if I combine it here, after coming out, this will be coming out as I1 plus I2. And what is I1 plus I2? It is nothing but I. So I can write as I equals to I1 plus I2. So I will be equals to V by R. I can use the Ohm's law because V is equals to I into R. So I will be equals to V by R. So I1 will be equal to, since the potential difference is same across all the resistors, so V will be constant divided by the resistor R1 plus V by R2. So V I can take it as common, so it will be 1 by R by equals to 1 by R1 plus 1 by R2. So this is the total resistance for the parallel connection. Okay, so this is how we have to do for the series and the parallel connection. Again, if you have any doubt, you can ask on my personal number. Thank you.